Welcome back, everyone, to another explainer. If you're geared up and focused on conquering the Cambridge AS and A-Level Mathematics 9709 syllabus, you are in exactly the right place. Today, we're zeroing in on one of the most notoriously tricky areas of the entire curriculum, Section 3.8, Differential Equations Using Initial Conditions. We're going to decode exactly what those examiners are looking for, going straight to the source material, the syllabus, and the principal examiner reports themselves.
Here is our game plan for today. First, the core principles. Second, the technical methodology. Third, critical evaluation skills. And finally, the top examiner traps. Let's get to it.
A senior examiner recently dropped this absolute gem of a quote. Most students lose easy marks on differential equations, but after this, you won't. Now, that isn't just a bold claim, it's a statistical reality. You see, students often drop points not because they can't do the calculus, but because they completely miss the specific expectations of the exam rubric. We're going to fix that right now.
Part 1. The core principles. Before we even touch the math, we need to understand the theoretical architecture of the exam.
Now, what's really interesting here is how examiners use a very specific rubric of assessment objectives, or AOs, to grade your understanding. First up, knowledge and understanding of basic principles. Second, application through systematic analysis. And third, analysis using evidence-based reasoning. If you just memorize your integration formulas, you're only hitting that first column. To secure those top-tier marks, you absolutely must satisfy all three domains.
The principal examiner reports explicitly highlight this next point. Candidates who demonstrate connected, conceptual understanding that transfers to unfamiliar contexts, are the ones who achieve top scores. For Section 3.8, this means your knowledge has to be adaptable. You aren't just solving some abstract equation. You might be modeling population growth, or maybe radioactive decay. Recognizing that the rate of change is proportional to the current amount, that is the fundamental key to setting up your initial differential equation in the first place.
Moving right along to Part 2, the technical methodology. Let's see how this builds into an actual procedural framework for exam day.
When tackling Section 3.8, systematic processing is absolutely essential. It makes complex problems completely approachable. Step 1, deconstruct the prompt to identify your variables. Step 2, separate those variables, get all the y's on one side and the x's on the exact opposite side. Step 3, integrate both sides. Step 4, and this is absolutely crucial, substitute your initial conditions to find your constant of integration, c. Finally, Step 5, rearrange everything to present your final particular solution in the required format.
So here is the real game changer, the method mark strategy. Examiners heavily reward systematic processing and clear working. The final answer is honestly only a fraction of the total points. By clearly separating your variables and documenting your integration steps, you're actively banking marks. Even if you make a tiny arithmetic error finding C at the very end, following this logical process secures the vast majority of your points and reduces a ton of anxiety.
Part 3. Critical evaluation skills. Let's talk about how to push a passing grade into the top-scoring bands.
Because beyond just crunching the numbers, Cambridge requires you to evaluate the context. Top-scoring candidates question assumptions and justify their decisions with evidence. Think about it. If you're modeling population growth using a differential equation, what actually happens as time approaches infinity? Clearly acknowledging the limitations of your mathematical model on your final conclusion is exactly what transforms a good answer into an outstanding one.
And this slide brilliantly illustrates the difference between a mid-tier response and a truly elite top-tier response. Mid-tier responses give you generic, context-free calculations. Sure, the calculus might technically be right, but it's just floating in a void. A top-tier response? That features specific, context-driven application. The math is tied directly back to the initial conditions from the prompt, complete with clear annotations explaining your specific reasoning.
All right, Part 4. Top examiner traps. Let's review the real data on where candidates usually crash and burn. Here are the top 3 examiner warnings straight from the source reports. Number 1. Using the wrong approach for the wrong context. This almost always happens when you rush Step 1 of our methodology and fail to deconstruct the question properly. Number 2. Forgetting to check format and presentation. Remember, presentation follows strict conventions in Cambridge 9709. Sloppy working will literally bleed your score. And number 3. Answers that aren't specific to the given context. If you find the general solution to the differential equation but forget to actually use the initial conditions to find the particular solution, you've walked right into their trap.
One final massive examiner alert for you. Candidates consistently confuse key mathematical terminology, which ruins their logic flow. Specifically, they blur the lines between a general solution, which includes your constant of integration, C, and a particular solution, which requires actually using your initial conditions. Knowing exactly which one the question is asking for prevents critical confusion and protects your hard-earned marks.
So what does this all mean? We've decoded the cognitive domains, we've built a bulletproof 5-step methodology, highlighted the need for evaluative thinking, and mapped out the exact traps to avoid. The only thing left now is implementation. Are you ready to test this methodology on real past papers? I highly encourage you to pull up a 9709 past paper today and actively apply this structured scaffolding to a 3.8 differential equations problem. Force yourself to write out the context. Check your presentation. If you found this breakdown helpful, make sure to hit that subscribe button so you never miss our next masterclass explainer. Keep your focus sharp, trust the process, and I'll catch you in the next one.